examples here. Examples of trigonal planar here. We could build BF3. BF3 is a strange looking structure. What's strange about BF3? Can you see it right off? There's something not right about this structure. What is it? Octet. The boron has only 6 electrons. It needs 2 more electrons to complete its octet. But I'm going to stop here. Why am I going to stop here? Yeah, because of formal charge. I don't want to form a double bond. If I formed a double bond, what would that do in effect? That would take an electron. Did you write down BEF2 in your notes? You have that in your notes? It was the same thing as BEF2, which is what? It was like 10 minutes ago. Just repeat, you know.
Yes, don't form double bonds.
Hmm?
Fluorine doesn't form double bonds.
Yeah, fluorine doesn't form double bonds. Why? Well, I'm sorry? Stanley, can you speak up here just a little bit? No, others, like chlorine can form more than one bond. Chlorine can form more than one bond. Bromine can form more than one bond. Chlorine can form a lot of bonds. Like in perchlorate. The fluorine wouldn't. Why? Perchlorate's got 4 oxygens bonded with chlorine. Yeah. Right. Well, chlorine would have to lose electrons too. You look at the charge. We're going to look at perchlorate later. Look at the charge on chlorine and perchlorate. What's the charge on chlorine and perchlorate? Plus 7. Plus 7. Apparently, it's lost 7 electrons. That would be the. But you know, that's an oxidation state. You know, what we're dealing with here is formal charge. And when we look at perchlorate, we'll see some interesting stuff. Perchlorate's a lot more complicated, so I don't want to talk about it now. I'm going to talk about it a little bit later today. We just want to start off with the simple one, make sure we're on the same page for the simple one, and then we'll do the complicated one. The reason is fluorine is the most electronegative, and so fluorine's a case of, you just memorize that. That's it. It's memorization. And so here, we're not going to double bond it. Instead, what we're going to do is we're going to just leave it like that. All the formal charges are 0, which is good. And this structure would be trigonal planar, because you look at the bonds, or the groups. It's trigonal planar. What about BF2 minus, the BF2 minus ion? If we look at the BF2 minus ion, it looks like this. Boron is going to have a negative charge here. I'm just going to give the whole thing a net negative charge. And so in this case, why didn't the fluorine get, well, the fluorine can't get a negative charge, otherwise it would go beyond its octet. And so boron ends up with a negative charge. And what is the geometry, the molecular geometry of this? This would be angular bent, and the angles we always measure via atoms. And so when we do an angle, we do the FBF angle. The FBF angle is 120 degrees here. And all 3 are the same. Right? It's 120 degrees here. But when we compare that to the FBF angle here, the FBF angle here is 120 degrees undistorted. ideal. But it turns out that these three groups don't have the same degree of repulsion. For example, lone pairs, do lone pairs require more space or less space than single bonds? Do lone pairs require more space or less space than single bonds? They require more space. Why do they require more space? Why do lone pairs require more space than a single bond?
Is it because there's no other atom holding in place?
Yeah. It's not being pulled by another atom. You know, lone pair is just concentrated on atom B. Whereas if you look at a single bond consists of 2 electrons, but it's being pulled towards atom F. And so that's going to, you know, whereas this is concentrated there. And so when we look at the space requirements, the lone pair requires more space, has greater repulsions than single bonds. And so having a lone pair there, what it does is it distorts the structure. And having a lone pair there, it usually results in about 2-degree distortion here. So plus 2 degrees, it'll push these in, and then this distortion is going to be about 116 degrees. And so this is just a total guess, 116-degree distortion. Or if you don't want to guess like that, you just say less than 100. But when people say less than 100, then you know it could be anywhere, 90, 67. You know, you aren't going to have that huge of distortion. And so the reason why I just say about 116 is to keep the degree of distortion reasonable. But you'll see less than 120 a lot. And that's because what happens is when you have the lone pair there, it pushes these in. So we could build these quickly with the brown. If you use the brown has 5 holes in it. 3 of the holes are arranged in a trigonal planar arrangement, and you can put long sticks for the bonds of the fluorine. Fluorine is a halogen. Halogens are usually the green ones. And a short stick for the lone pair. You want to try that and see. Go ahead and build that.